So big topics for our class, what I'm going to be testing you on and what I think is essential for Algebra 2 from last year to this year. Number one is, the first category is system of linear equations or functions. All right, so it's a system of linear functions and equations. System. And the reason why I even say that, and instead of just saying linear function, is because if I think in terms of system, I will be testing you about all the intricate knowledge about the linear functions, right? So for example, do you need to know the point slope form or y-intercept form of the equation, be able to manipulate in a way that helps you understand how that shows up on the graph, okay? You know, the system equation solving for x and y, when there are two equations, I want you to be able to graph them, meaning that they're the intercepts. So I'm going to talk a little bit about that. I'll show you some examples of that means. Second types of problems that I will probably test you on is a system of quadratic functions. Right. So the first kind of test will be, graph will look like, you know, system equation will be like this, like f1 and f2. Function 1, function 2, solving for the intercept, things like that. System quadratic equations, system quadratic functions could be, say, you know, you have a graph look like this, and then you have a graph look like this, and then you're solving for the intercept, right? So, and those kind of equations, meaning they are squared, right? Squared. So one is to the power 1, second type is squared. Next types of is I want to look at irrational functions. So this has to do with root functions. Right, so these has to do with irrational functions that's not going to be able to clearly define as something over something. And so I will be looking at square root functions that will ask you about the domain and range and things like that, simplifying expressions, things like that. And then the next one we have gone over rational functions. Rational functions. This is typically chapter 5 material. Exponential functions, and the inverse law functions. That's chapter 6. So it's really just these 5 topics. 5 topics. Very, very simple. I think it's very simple. Let's take an example right here. And this one, I'm going to just jump right into number 2, quadratic. This has to do with quadratic. Okay. So consider this will a problem will look like on the test. Consider, and I'll shorthand it quite a bit. So, but on the test it will be more in detail. Negative 2x squared plus x plus 1, part A. So there will be multiple parts in each problem. Part A, by inspection, what kind of graph does this function have, and y. Part B, find the coordinates of the vertex H and K. C, find the y intercept. D, find the x intercept. And lastly, E, graph fx. This is the kind of problem I will give on the test. So if I say you will have 7 problems, each problem will look like this. Okay? So go ahead and try to solve this. You start out with this first one, this equation. This is the equation, very simple equation. I just want you to kind of take a deep dive on this equation. And without using calculator, or I guess you can use calculator, but the problem is really asking you by inspection. What that means is you want to say what kind of graph this function has. You want to say, oh, this graph is this because of this thing on the function. This graph will have this because of this thing on the function. Does that make sense? I'll give you a head start. This graph is a parabola. This graph is a parabola, and then the y is because it has a square on the x. This is a parabola, is an upside down parabola going facing downward. Why? Because it has a negative for the x squared term. Does that make sense? So those are the kind of things that I will be asking you. That you look at this and you say, okay, well, how can I imagine what this will be and why? There's a reason for everything. So, okay? We'll allow out there. Part A, by inspection, what kind of graph it is, you can say a parabola. We are all parabola. What you can say is, you can say this is a parabola, so x squared term, negative x squared term. Okay, so you can identify that. Right? B, vertex. You can see that well, okay. I'll use the black. Okay. So you can say this is a parabola going upside down due to 1 x squared term and 2 negative x squared term. B. Now vertex H and K. If you remember vertex H is equal to negative b over 2a. Negative b over 2a. So if f of x is equal to negative 2x squared plus x plus 1, a is equal to negative 2, b is equal to 1, and c is equal to 1. Right, so those are the 3 constants. So what that means is that h is negative b over 2a, so it's negative 1 over 2 times negative 2, so you got negative 1 over negative 4, which is 1/4. Okay? 1/4. So you know that your highest point of the vertex of your parabola is going to sit at x equal to 1/4. Now the coordinate requires the y value, so the k is taking 1/4 and then put it back into the equation, right? Put 1/4 back into the equation. So negative 2 times 1/4 squared plus 1/4 plus 1. Let's take a look at what this is. This is negative 2 times 1/16 plus 1/4 plus 1. This is negative 1/8 plus 2/8 plus 8/8, which is 7/8. No, 9/8. 9/8. So your vertex is at 1/4 and 9/8. 1/4 and 9/8. So that's really simple. So at least we know that. Now, part C, we want to find a y-intercept. Y-intercept, right? Meaning the graph that hits the x-axis. When the graph hits the x-axis, y is equal to 0, right? No, I'm sorry, that's the x-intercept. Y-intercept is when x is equal to 0, right? The graph that crosses the x-axis, right? The y-axis, the f of x crosses the y-axis, and when it crosses the y-axis, the x has to be 0, right? So, yeah, if we imagine that this is some sort of graph goes like this, we need to figure out, well, what's the y-intercept? So x is equal to 0. So for y-intercept, set x equal to 0. Set x equal to 0 and put 0 into the function. So f of x, f of 0 is equal to negative 2 times 0 squared plus 0 plus 1, which is equal to 1. So y-intercept is at 0 and 1. 0 and 1. So far, so good? You follow along? Part D? Okay. Now, see, part D, you want to find x-intercept. Now, x-intercept, say for example, x-intercept, say this is just a sketch. This is a mental sketch. This is not a real graph, but it could be the real graph. We found the y-intercept, which is at 0 and 1. We know the highest point is 1/4 and 9/8, which is a little bit higher than 1. X-intercept will be, you look at this graph, you know that there's going to be 2 points, right? 2 points. And that is when y equal to 0, right? When y equals to 0. So for x-intercept, you want to set the f of x equal to 0 when y is equal to 0. So that means y or equal to f of x, and you want to set that equal to 0 and find x's, right? You want to find x. So this turns out, right? This turns out, let me just erase this part so it's easier for you to see. I wish you would have those college lecture hall whiteboard. It's shoots it up. So this one, finding x-intercept, setting y equal to 0, we have f of x is equal to negative 2x squared plus x plus 1. We set that equal to 0, and we're trying to find x. Then if you just look at this becomes a quadratic equation solving for x, right? I mean, that's why we break it down in those little small, specific sort of drill and kill and drill type of problems. Talking with your computer. Yeah. So as you can see, then that's just solving for x. So go ahead, you know how to do this. You can what can you do? You can try to factor, or you can try to use quadratic formula. Right? You can try to factor, or you can try to quadratic formula. Can this be factor? Is this factorable? I think so, right? Let's try factor. If we do this, what would it be? Negative 2 by 2, 1, 1, 1, negative. Is it factorable? Maybe it's not, huh? Is it? Negative 2, 1 plus, no. I don't, unless it is. Oh, it is. So this is 2, this is negative 1 plus. Do you guys know how to do this? Right. So this is. Have you guys done this before?
Yes, we have without coefficients. We've done this, but not with coefficients.
Okay. So here I'll show you how. Do you want to learn this part? Okay. So I came up with this factor, and if you multiply it out, you should get back to this. Right. That's one way to check it. This is what I do. I'll start over again. I'll show you again. I'm suspecting that this is factorable. Nice, easy factor. This number, and then there's a number, right? This is 1 in front of it, and this is 1. So I look at this negative 2, and I say, what are the two multiples that can make it into negative 2? 2 and 1, 2 times 1, or negative 2 times 1, or 2 times negative 1. So I have a choice of negative 2 and 1, or 2 and negative 1. That will go with this number. And then this number is 1, so one multiple that makes it 1 is 1 times 1, or negative 1 times negative 1. It all depends. Now, I'm going to start with this, and I will adjust from there later on. The way I do it is I take this top number and multiply this number. Negative 2 times 1 is negative 2. 1 times 1 is 1. The combination of these two numbers has to make it up into the middle number. 1 minus 2 is negative 1. That's not that. I need positive 1 here. So I say, well, what can I do to change this? Well, I can change this by doing the same thing, but I can change this by making the 1 here negative and make 1 here negative, because negative 1 times negative 1 is still positive 1. But it changes things. Negative 2 times negative 1 becomes positive 2. Negative 1 times 1 becomes negative 1. Negative 1 plus 2 becomes positive 1. This one matches the middle number. So what that means then is I will have a combination of negative 2 and negative 1, 1 and negative 1. So negative 2, negative 1, 1, negative 1. Put an x here, put an x here. That is your factor form. Yeah? So far so good? So what that means is that negative 2x minus 1 is equal to 0. X minus 1 is equal to 0. So this is x is equal to 1. That is one of the zeros. Over here, negative 2, x is equal to positive 1. X is equal to negative 1/2. So these are my x-intercept points. These 2 points. Now actually the coordinates for that, right, is 1 and 0, negative 1/2 and 0. Those are the y-intercept points. For this one, right, for the y-intercept points, we already have the coordinates 0 and 1. And we have the vertex which is 1/4 and 9/8. So now I'm ready to graph, which is the last part of this problem. So the last portion of this problem, I'm going to erase this part so I can graph it for you. I can sketch it using, without really being super precise. I simply need to be precise on those critical points. So number one point is the vertex. Vertex is at 1/4 and 9/8. 1/4. So if this is say 1 and 2, let me see, 1. Let's make it this way. 1, 1, 1, 1. So 1/4 will be right here. So this is 1 here, 1 here, 1 here, 1 here, -1 here, -1 here. 1/4 will be right here. 9/8 will be right here. So I have a vertex. 1/4, 9/8. 1/4 and 9/8. My y-intercept is 0, 1. 0, 1. So here is my y-intercept at 0, 1. So the graph is going to come through and hit this point. And then this is the highest point, so it's going to go that way as well. Now I need to have 2 more points. I have x-intercept at 1, 0. So it's going to land right here. This is landing right here, 1, 0. So this thing is going to go down and shoots right here. So I have one side of my graph done, and on the other side is -1/2, 0. So -1/2, 0 is right here, -1/2, 0, -1/2, 0. So this graph is going to hit this way. So there you go. I have all the elements of a precise graph with this function. Yeah.
So the graph is always going down because it's negative or
Yeah, it comes down because of negative. Yeah, so the negative with the x squared term, with the positive and negative on the x squared term depend what dictates the way in which it opens. Right? So if it's a positive x squared term is always parabola up, and the negative always comes down. Questions on this problem? So I just help you review a quadratic that touches upon all sorts of parts of the quadratic, right? So you got a factor going on, but the factor is in the factor problem is in the context of solving solving for x-intercept. Simply setting it equal to 0 and solving for, or setting x equal to 0, that's solving for y-intercept. Finding the vertex and so on. Okay. Can I erase this now? That's fine. Example. This is a rational function. This is a rational function question. Consider f of x is equal to x minus 3 over x squared plus 5x plus 6. You remember this, right? We've done something like this. That shouldn't intimidate you. Part A. Factor the denominator. Write f of x in factor 4. So go ahead and do that. I'm going to write down a few more parts, but you can do the first one right now. Okay, try that. Okay, let's start with part A. In the interest of time, I'm going to fast track this problem. So we want to factor the bottom, right? So factor x squared plus 5x plus 6. Now remember earlier I done this, right? I'll break down the method I used, even though this could be a very easy factor for you. This one right here is 1 and 1. This 6 here is 3 and 2, right? I mean, it could be 6 and 1, but 3 and 2 works too. But what happened is that the advantage of this is that 1 times 2 is 2, 3 times 1 is 3. It's positive 2, positive 3, that gives you 5, gives you the middle number. So that means this combination is the right factor. So then you end up with, right, this factor, 1 and 3, 1 and 2, they're plus, so it's 1x plus 3, 1x plus 2. So x plus 3 and x plus 2.
You're doing a different way than how Mr. Phillips originally taught us last year.
Oh, okay. Whatever that was for you.
No, yeah.
Yeah, it doesn't matter. There's different ways to solve the problem. Right. So the different way to think about it. Whichever way that is easy for you to solve problems. All right. So f of x. Now we end up with x minus 3 over x squared plus 5x. But actually, we'll just factor this out. Factor this out. So we factor it out, we end up with x plus 3 and x plus 2. Now, we end up with a function like this in factor form. And, you know, you will wish that they come out with a different factor so we can cancel stuff out, might be easier. Turns out that it's not that easy. It's not, you know, you can't cancel anything. So it turns out that it is what it is. Now, part B is, well, what x values would there be vertical asymptote? Vertical asymptote, if you think about it, this is where I'm going to test you on how you think about function. Anything that has a vertical, say this is the xy axis, and say a graph happens to have a vertical asymptote. That means the graph cannot, whatever the function that you have can, you know, has to, you know, go up, but never touching this value, right? Never touching this value. This value right here, this whatever this x value is. Now this x value for the function has to be undefined, right? It has to make the function undefined because whatever this x value is, you never get to a real answer, like not a real value for the function. So you have to make the function undefined. Now, how do you make a function, a rational function, undefined? whenever we look at a rational, say, number, and we say it's a undefined number, usually it's what? Usually, what happens when you will say something like that? The bottom of the fraction is 0, right? Like something divided by 0 is undefined. Something divided by 0 is undefined. So this function will become undefined if the bottom part becomes 0. Yeah? Yeah? F of x becomes undefined when you got x minus 3 over 0, right? But 0 right here, that means x plus 3 times x plus 2, you set them equal to 0, then you say, when x is equal to negative 3, the function is undefined, because it will make the whole thing equal to 0. Or x is equal to negative 2, when x is equal to negative 2, the whole thing becomes 0, undefined. So I know that, hey, immediately I know that at x equal to negative 3 and x equal to negative 2, I'm going to have vertical asymptotes. Yeah? Make sense? So here, whatever this graph might look like, I have no clue at the moment because I haven't touched my calculator. I'm just purely just reasoning myself through this, right? I know that negative 2 right here, negative 3 right here, somehow I'm going to end up with these dotted line right here, vertical asymptote. Okay? So then the question then is, well then what would this graph actually look like? Part C says graph f of x using the information found in part B. So this is the whole thing, not using calculator at all at the moment, is to kind of, I'm testing you to see if you're able to kind of reason your way through this problem. Now, part C is very simple. I mean, imagine this is already part C, right? So this is part C. So all I really need to do is to figure out some points on this side of the asymptote. I need to come up with some points in between the asymptotes, and I'm going to come up with some points on the right side of the asymptotes. And the way we do that is pretty simple. I can just use XY table. Right? I can use XY table. Easy one to do is on the right side of negative 2, right? On this side, I'll just put x equals 0. When I put x equals 0 and put it back into this function right here, or this function right here, that means negative 3 over 3 times 2, which is negative 3 over 6, which is negative 1/2. Negative 1/2, so negative 1/2. So 0, negative 1/2.
It's like right between that. Sorry.
That's okay. Just keep reminding me. So 0, negative 1/2. So I got a point right here. Now my curiosity is whether this is going to go up like this, or this one is going to go down like this, because I know that at least I got this point. So my graph is going to go through this point. But this graph can go like down this way or up this way. So one way to figure it out is just pick a number on that side, right? And see which direction it goes. I just need one more point to know which one. Like if it's a little higher than negative 1/2, I know it's going to go up like this. If it's below negative 1/2, it's going to go down like that. Yeah.
You're saying to just pick a number and plug it into x?
Yeah, because I know that the graph is going to go through this because I already come up with the right point. This one shows up on the graph, right? Right. So this point that I did, I randomly choose on the right side of negative 2, x equal to negative because it's on this side of the asymptote. I chose this one, so I come up with this point. So all I need to do is come up with another point. So in this case, maybe I can do the negative 1 here. The negative 1 hasn't been touched, so I'll do negative 1. X equal to negative 1. So if x equal to negative 1, I got -1 minus 3, so it's -4, right? And then -1 plus 3 is 2. -1 plus 2 is 1, so 1, so then this one is -4/2, which is -2. -2. 1, -2. So I got this point. So I know that this function is going to go like this. I go down. Because it can't ever touch the asymptote, so it has to fly really close to it. And it's going to go down this way. So I know that at least I got this answer, right? Now I can go on the other side. I can say, okay, how about on this side? Let's do the -4 here. Do a -4. -4, and I put -4 in here. I end up with -7, right? -4 minus 3 is -7. Divide -4 plus 3 is -1. -4 plus 2 is -2. So this is -7 over 2, right? Which is -3.5, right? So it's like right here. So if we had asymptote this way, then you got to figure it out. And okay, well then, what's going to be? Is it going to be going down this way or that way? I mean, one way to do it is I can figure out what -5 is going to look like. If -5 is down below, then it's going to fly out this way. If the -5 is a little bit above this point, it's going to go down that way. So -5. Let's put -5. -5 minus 3, so you end up with -8 on the top. -5 plus 3, right, is -2. -5 plus 2 is -3. So you got -8, 6. -8, 6. -8, 6 is what? Is -1 point something, right? So -1 point something, -1 point something. So it's right here. So if this point is right here, this point is right here, and asymptote is right there, it must go like this. Okay? And then all you need to do is look for a point in between. And then there you go. And then so then how do you find domain? In domain, then you can say domain is very simple. I mean, depending on what value you find in between, but I bet that you got points in between, and probably will look kind of funky. It'll probably look like a parabola inside. So I'm going to skip that for the interest of time. But domain is probably going to be very likely to be right. Domain is going to be actually. Let me do it this way. Domain is going to be right. -infinity to -3, and from -3 to -2, and from -2 to positive infinity. That's the domain. That's the domain. So far, so good. Okay, one more problem, and this one is going to be on linear equation, linear function. I know we only have 8 minutes, but I'll see if I can go through this as much as possible. Let me erase this one. I will put this on the video so you'll be sure to have it. This is on a linear function. I'm going to read this real quick because usually it will look like this. It's a or problem, and you have to really decipher. Listen carefully. When you die, nitrogen from the air you breathe dissolves in your blood when you die. The concentration of nitrogen in your blood varies linearly with the depth at which you are swimming. So here I said the concentration of nitrogen into concentration of nitrogen N2 nitrogen. Is nitrogen N2 or just N? Nitrogen varies linearly with the depth which you swim. Okay? At 20 feet, you have 190 milligrams of nitrogen per liter. So that's the concentration. At 30 feet, it's about 225 milligrams per liter. And part A is to plot a graph. Part B is to write a particular equation expressing this relationship. Part C is predict the concentration at 100 feet, and so on. So there's a bunch of different parts of the problem. Let's start with this one. If you were given a word problem like this, you really had to just write it down like this, and here is a key statement on the problem. The key statement here is to say that the concentration of nitrogen varies linearly with the depth in which you swim at. So this concentration is a dependent variable, right? And then the depth is the independent variable, and it's a linear function. It's already saying it's a linear function, and it gives you two data points. So in a sense, you can say this is x and y, right? Y is the concentration, and x is the depth. So you got 20 and 190 right here, and then you got 30 and 225 here. And you're supposed to find a function equation. Do we know how to do that? Point-slope form, right? Yeah. Point-slope form. So point-slope form says y minus y1 is equal to m times x minus x1. The first thing you need to do is you need to figure out the slope. My slope is y2 minus y1 over x2 minus x1. So you got 225 minus 190 over 30 minus 20. So what do you have? 35, right? 35 over 10, which is 3.5. Then your equation, you can pick any one of them. You can pick any one of the points. You can use the 20 and 190, or you can use the 30 and 225 and put it back into this equation. So you have y minus 190 is equal to 3.5 times x minus 20. Simplify this, then you have the equation to work with the rest of the problem. Right? So the problem itself, if I had given you a word problem like this, may look intimidating, but when you begin to decipher them and pull out the essential information, this is what you're going to get, and it's going to become very, very simple. Don't get those words like concentration of nitrogen or whatever to intimidate you. I'm going to try to intimidate you with those big words. but you're going to be able to say, oh, no, that's, whether I understand it or not doesn't really matter. Well, I need to understand is the path. If it's always saying it's a linear function, linear relationship, so that's a linear function.
Is that like y minus 190?
Right. So Now, this is a function. You can leave it as such. I mean, of course, this is not a very pretty function. One could say that you could write it as y is equal to 3.5x minus, I mean, what's 20 times 3.5 is 70 minus 70 plus 190. So then you got y is equal to 3.5x plus, what is it, 120. So that's the equation you work with. Right. And then so then later on, I'm going to ask a bunch of questions and I say, hey, what's the nitrogen concentration at the depth of 100 feet? It's easy, right? You just put 100 into x, come up with y. If I say, hey, you know, at what point would you get 680 milligrams? Well, then you put 680 milligrams into y is over x. Right? And I say, okay, can you graph the model, can you graph the function, the model, using the concentration and the depth? Graphing a linear equation. Easy as that. Got it? Have a good day.